Okay, so we're going to write down statement number one should be angle 1 and angle 2 form a linear pair, okay? And the fact that KI bisects angle HKJ. When you're given information as multiple facts, we have fact 1 and fact 2 here, I think it makes sense to kind of stagger them in their own lines here. So what I mean by that is something like this. If you have room and you start writing it like a sentence, a lot of times if you keep writing this as a sentence, that second part of your given, which you will need at some point in the proof, you forget that it exists. You forget that it's there, okay? But if I write it as its own kind of line down here, I will remember that I need to target that idea. Something about proofs is, guys, just seeing it one time, just doing it together one time in class, it won't be enough to really master these. We don't have enough time to go over enough of them to master them. But if you get online and watch the videos of these, you do them again. Maybe you go home, you say, okay, I want to start with this one again and try to go through it myself without any instruction, any guidance, and then watch the video and see if kind of the ideas match up. That practice back and forth will develop a much better proficiency in these things. And on my website, I've got many other videos of many other proofs from other people doing them that you can practice as well. Okay, I will try to, in class, target the ones that are most aligned with what we're doing and most appropriate for the end of course exam. But to really get a good grasp of this stuff, you're going to need to do some maybe legwork on the outside of class, kind of on your own. If you're a person that struggles with these, eventually, okay, you're going to find out that there will be people in this class that instantly get it, 100%, and they're like, this stuff is cake, this is easy, and there's some people who are going to struggle. Okay, if you're a person that struggles, don't get bent out of shape about it, okay, but at the same time, don't let it be something that festers, okay? If you struggle at it, you recognize that you struggle at it, what are you going to do about it, okay? Because these things won't go away in the near future, okay? So please, if something doesn't make sense, we take the initiative to figure out how can I get better at them, what can I do? I ask questions, watch videos, that kind of stuff. It will make your life a lot easier the faster you can realize whether you're getting this or not so that you can adjust for them, okay? But I think as we first go through these, it makes sense to talk about them kind of logically and then actually go through the proof. So if I look at this, it says angle 1 and angle 2 form a linear pair. What does it mean when they're a linear pair? Okay, they form a straight line. And how many degrees is that going to give me then? 180 degrees. So we know 1 and 2 are going to add together to give us 180 degrees, right? Okay. Well, the next statement says that KI bisects angle HKJ. What's it mean when we have a ray bisecting an angle? What does that do? What does bisect give us? Or what does the word bisect mean? Bi means two, right? Okay. Sect means sections. So two sections, but that's not enough. What is going to happen if I take a sandwich and I bisect the sandwich? I'm going to have what? We don't know what bisects means. Bisects. Don't know what it means. Nobody has notes that they could search through and say, I know what bisects means because my notes say this. We have two equal parts, right? Okay. So when we bisect angle HKJ, we're bisecting it to two equal parts. Okay? So if they're going to add up to 180, and we've got two parts that are the same, okay, 1 and 2 are going to add to 180, but they're the same amount, what amount do they both have to be? They both have to be 90, right? That's logical. Okay? Well, if they're both 90, what can I classify either one of them as a right angle. Okay? So that logic right there gets us from our given information down to what we wanted to prove. Our proof that we're actually going to write is that step-by-step kind of analysis. The only thing is that we can't make conclusions that aren't valid. Okay? I told the last class, when you guys write a paper, when you guys write a English paper, does your English teacher talk about the audience that you're writing for? Like so when you write a paper about, let's say you're in Mr. Sod's class. You guys read Romeo and Juliet last year? Did you guys write a paper about it? When you write that paper, he's your audience, right? You're making the assumption that he has read Romeo and Juliet, and when you're talking about things, you don't need to be, explicit in every single thing that you say because he's read the book, okay? When we write our proofs, we have to understand who our audience is, okay? A lot of times we want to make the assumption that the audience is an individual or a group of people that are equal in our mathematical intelligence or lesser, okay? So we should be able to give this to maybe somebody in the grade below us who hasn't taken geometry yet, and they should be able to read it and still kind of understand what's going on, okay? That being said, you can't skip things. Does that make sense? You can't make a conclusion. You can't go from one step to another that we all understand, but maybe a person in the grade below us wouldn't understand, okay? So I can't make the conclusion, the jump says linear pair, and automatically go, well, that means they add to 180. Because when somebody sees linear pair, and they don't know what that means, what they're going to do is they're going to look that up in a math textbook. And in a math textbook, it's going to say that the two angles that are supplementary. And nowhere does it lead them to 180 degrees until they look up what supplementary means. Does that make sense? So you have to be very explicit, very detailed in your steps that get you from argument number one to your final conclusion. Okay? So we've got a linear pair. So those 7 steps I gave you yesterday are going to allow us to do that and to be very efficient at doing that. So those 7 steps, the first one said, obviously write your given down. The second one said, if there's any congruent symbols, if you see, and you'll see a couple of these here in a moment, and in the next proof we do. But if you see that symbol or that symbol, you need to go to your picture and draw in to your picture those relationships. We don't have those symbols in our first statement, right? So we can skip that. Number 3 on that handout said, you're going to look for vocabulary. So what I always do is I go through my given statement and I just highlight the vocabulary. And let me close this out real quick and then open it back up. It's being weird. I'm going to highlight my vocabulary so that I don't forget to talk about one of them. Okay? So linear pair is a vocabulary word. Now that is a unique vocabulary word. Okay? So it behaves a little bit differently than any other vocabulary words we talk about. The other vocabulary word here is bisects. Okay? When we see those terms, okay, we need to write down what those mean to us. What does a linear pair mean to us? Okay? By definition, a linear pair are two angles that are adjacent, whose non-common sides form a straight line. Okay? In that definition, it's more of what we call an existence definition. There's not a lot of substance to that. It just shows me how I make them. Okay? What provides us some substance that we can use here is the fact that if we have a linear pair, we have a statement that says any set of linear pairs are supplementary. And the statement that came out of back in section, I think it was like 1.4 or 1.5, something like that, we started talking about angle pairs, is the linear pair postulate. The linear pair postulate, word for word, says if two angles are a linear pair, then they are supplementary. Okay? So when we see the word linear pair, we cannot jump to the conclusion that we get the number 180. When we see linear pair, we have to jump to the conclusion that they're supplementary. And now what does that supplementary tell me? So here I introduced a new vocabulary word. What does supplementary mean? That's when we have two angles out to 180, right? So now I can say the measure of angle 1 plus the measure of angle 2 is 180. Okay? So every single time that our given statement has vocabulary, we're going to write down what that vocabulary word tells us per our problem. And I say per our problem, I'm going to use kind of the identified features in our problem, like angle 1 and angle 2 here. Or maybe for some reason we'll talk about HKJ at some point. So our specific angles and segments and that kind of stuff in our problem in regards to them being, in this case, a linear pair. That introduced a new vocabulary word. That introduced supplementary, right? So every single time on the left-hand side that I introduce a vocabulary word, because of some other argument, some other reason, I have to identify what that vocabulary word tells me. So we introduce supplementary, so then we have to tell what supplementary means. But we're going to be specific to our problem. We know 1 and 2 are supplementary, so we're going to write that measure of angle 1 plus measure of angle 2 equals 180. Does that make sense? Okay. So the next thing we want to do is write, why did I know that? Why did I know that when somebody says you have two angles that are supplementary, that you can say that they add up to 180? Isn't that because we know what supplementary means? And why do we know what supplementary means? Where is the phrase, or what is the phrase that provides me that information? We'll call it. It allows me to categorize or identify or itemize, I don't know if that's the best word, what these angles are. Whenever you, definition. The definition of supplementary angles. Okay? Now, it's just because of the convenience of less writing, I'll always write statement 3, in this case, definition of supplementary angles. If you wanted to write out what the actual definition phrase was, two angles whose sum to 180 are supplementary, that's what the definition says, right? If you want to write that phrase out, by all means, have at it. Okay? But I'm going to write definition of supplementary angles because it's just less to write. Is that all right? Okay, so in that statement, we didn't introduce any more vocabulary in statement number 3. Okay? So linear pair, that blue vocabulary word got me to introduce that pink one, but there's still a vocabulary word up there, right? Let's talk about what that bisect means. You told me bisect meant cuts into equal parts, right? And we've got angles being cut into equal parts. So if I look at KI, look at my picture, KI being that ray right there, it cuts angle HKJ, which is that straight angle, it cuts it into two equal parts. Well, those two equal parts are angle 1 and angle 2. Okay? Now, if we were to actually look at any definition, any textbook you look up, you Google this stuff, you type in, what does an angle bisector do, or define an angle bisector, it will state that it takes a larger angle and it divides it into two smaller congruent angles. It never says anything about their measurements being equal. Does that make sense? It says they're congruent shapes. So, this is why we write angle 1 is congruent to angle 2 instead of saying measure of angle 1 equals measure of angle 2. Now, we wrote, and so this one was unique. I said that one was unique because it's one of maybe 3 vocabulary words that when we write something down, the reason will not be that vocabulary word. Here, bisect is a normal vocabulary word for proofs. And the fact that when you write something down that you know to be true because you looked at that vocabulary word, your reason will be the definition of that vocabulary word. So we're looking here for the definition of an angle bisector. Okay, now I know it doesn't say angle bisector, but that's what we're dividing, right? That's what we're bisecting. If you just wrote definition of bisector, that's fine. You get credit for that. But I think being specific there with angle is a good idea. Okay. Now what we want to do is look at this thing here. Look at this equation stated in number 3. Okay? And then I want to do a little bit of work. And you're going to see eventually, this might not be obvious the first time we do these, but eventually you'll start to see patterns within these proofs. But what I want to do first, because this is a number, that's a number, and that's a number. Would you guys agree with that? Now, I don't know what those numbers behind measure of angle 1 symbol are and measure of angle 2 symbol. I don't know what those are. But I want to do a little bit of replacing here in a moment. And those are numbers. But down here in this red statement, these are shapes. That's a shape. That's a shape. I don't have the ability to replace a number with a shape or a shape with a number. Does that make sense? If I want to use substitution here and think about like athletics or something like that. If I'm a coach and I want to substitute somebody in for a game, okay? Let's say I want to take Hunter out of the baseball game and I want to put somebody else in, okay? I'm going to put another human being in, right? Okay, I'm not going to take Hunter out and put in a farm animal, right? Okay? I want to be able to replace him with something that is equal to him. So I can't replace a number with a shape or a shape with a number. So what I want to do, eventually I want to replace one of these numbers with something else. And it's going to be one of these things, but they have to be in the version of numbers. They have to be in that format. Would you guys agree that if I have two angles that are congruent, then we know that their measurements have to be the same number? If I have two angles that are congruent, that means they're both maybe 30-degree angles, or they're both 45-degree angles, or they're both 90-degree angles, or something like that, right? So now I convert a congruency statement into an equality statement, and that reason is the definition of congruency. Okay, yesterday we saw it in one of our proofs that said congruent segments have equal lengths. Well, congruent angles have equal measurements. Okay, so it's the same thing. What's going to happen, guys, is eventually you'll realize those two steps and most questions, most proofs will come as a pair. Once you write the first one, you'll automatically know that I got to write the second one. Okay? It's an author thing. It's, you know, you guys take different English classes. You know, Mr. Style might teach you maybe one appropriate way to write a paper. Okay? And then Mrs. Ellington might teach you maybe another appropriate way to write a paper. It's a little bit different than Mr. Stidle. And Mrs. Yu might do the same thing, which is a little bit different than both of them. Does that make sense? Okay, there are many different versions of prose writing. Everybody writes a little bit differently, right? So when we write proofs, authors write them a little bit differently. Some authors will not write statement number 4. They will say, instead of statement number 4, they will jump straight to statement number 5. Okay? Right now, I want us to be as detailed as possible, as deliberate as possible, so I'm going to ask you to write those things. Eventually, later on, maybe we'll relax on that a little bit, but right now I want to get used to that. Okay, so those two things, like I said, those are going to come together. Now I'll write statement number 6. And statement number 6, don't write this down yet. I'm going to have measure of angle 1 plus measure of angle 2 equals 180. Now that's kind of stupid to say, because that's exactly the same thing as statement number 4 said, isn't it? Or sorry, statement number 3. I didn't write anything different there. So that's kind of dumb. But look at this blue statement. Isn't 1 the same thing as 2? So can't I come right here, instead of saying 1 there, put 2? Does that make sense to everybody? So I'm going to rewrite that as a 2. And I think you'll see here in a moment why we're doing it. Remember, the overall question was, can we get to the point of being able to say that angle 2 is 90 degrees? So as I'm doing this substitution, I want to leave 2 in my problem. I don't want to get rid of angle 2. But that's the idea, right? I took this statement here, number 3, and wherever I saw that right there, I replaced it with what it was equal to. Measure of angle 1 is the same thing as measure of angle 2. When you replace something with what it's equal to, Substitution. And now we're almost done. Because remember, measure of angle 2, that's a number that we don't know, right? That's like a variable, right? It's like x. You have x plus x up there. How many x's would you have? You'd have 2 x's, right? So here, I actually have 2 measure of angle 2's. You can call that combined like terms. I think we talked the other day that your math excels, they'll call that the distributive property. Okay. But if I have 2 measure of angle 2's equals 180, what does 1 measure of angle 2 equal? If I want to isolate this variable term here, what would I do? Divide both sides by 2? Okay. Now what I want you to understand, and this is the jump that a lot of people want to make, or they just want to stop here, because, oh yeah, 90 degrees, angle 2 is a right angle, right? But remember who we're writing this for. We have to make sure that we make a conclusion that matches up to the proof here. Okay, so when I say measure of angle 2 equals 90, that's not saying this yet. Okay, so I want to go one step further. If I know I've got an angle that's 90 degrees, so angle 2 is a right angle. Okay, whenever you state that something is whatever, something is a right angle, something is supplementary, something is complementary, okay, you're classifying something, right? You're categorizing it. You're putting a label on it. And the only way that I can maybe label you as a sophomore or a freshman or a junior or whatever is if I know the what of a sophomore or the what of a freshman. How do I label you? How do I categorize you that way? By the what? Say again? Description, and description is provided in the close. It's in the definition, isn't it? Does that make sense? Okay. So angle 2 is a right angle because in the definition, they lay out that description that it's got to be equal to 90 degrees. Okay. So whenever you make the argument that something is some object, okay, angle 2, that's my something, is placed in this category of being this type of angle, your reason will be the definition of whatever you called it. Definitions are categorizing phrases, labeling phrases, okay, grouping phrases that allow us to do those types of things. So when I make a declaration that something is a right angle, it's based off knowing what the definition of right angles is. Okay, so that's the full argument of kind of what we said at the beginning when we just kind of laid it out logically. Well, yeah, those both have to be 90 degrees because they're two of them that are the same. They have to 180. If they're both the same, they both got to be 90, right? But that is the foolproof logic of that argument. Okay, and that's what we're looking for inside proofs. Now, some proofs will be, I think, kind of long. 9 statements. Some will be 9 statements. Some will be 4. Some will be 5. I think at one point during the year we do one that's like 23 steps or something like that. But they vary. You don't know what they're going to be until you start working through them and sifting out these ideas. Okay? Most of the time, they're going to be less than 10 statements. Okay? But there's an occasional long one. I will do this one and we'll be done. See you. Have a good evening. All right, so this one here, there are two statements in the given, right? Two facts that they're trying to give me. And those vary as well as we go through varying proofs. There might be one statement that they give me. There might be two. Sometimes we'll see 3 and 4. It just depends on the particular problem. I'm going to, so statement number one, or step number one on that worksheet I gave you yesterday said, write your given down. We did that. Statement number two says if there's anything in your given in regards to an equal sign or a congruency symbol, you want to draw that in your picture. And all I mean by that is come up to your picture and put that marking in it. And the reason we're doing that, it's not a big deal in this particular problem, but the reason that we're doing that is that eventually we might have 7 or 8 steps on the left-hand side, and I'm looking for one more congruency to help me out in a proof. And it's a lot easier to look at my picture and figure out what that one more congruency might be than it is to go through 8 statements of written work to try to figure that out. Okay, so you've heard the phrase, a picture says 1,000 words, right? That's kind of the idea. We want our picture to be very informative to us, and if we're not updating it as we're working through the problem, we're going to be, we'll struggle with this process. Okay. The next thing I would do is when I get a congruency here, and it happened in the last question when we developed a congruency, so this is a pattern thing. Here we had a congruency in step 4, right? The step after that, we talked about how their measurements were equal. That might be something that you just come accustomed to doing. Angle 1 and angle 3 are congruent, so I'm just going to say measure of angle 1 then is the same as measure of angle 3. And being able to do that, being able to jump from congruency to equality or equality to congruency, we can go both ways, is that definition of congruency. Last class, if you were to look at somebody's notes from last class, we didn't do that until step 5 in this problem. Okay? But I think it makes sense to maybe do it here first. And we'll talk about eventually the order of these steps when we're done, and why they did it at step 5 and why we can do it at step 2. All right, so step 1 and step 2 on that handout are done. Now we get to step 3, which says vocabulary words, right? Are there any vocabulary words in our given statement? Right angle. So let's write down what right angle means to us. Now we got to be specific for our problem. So which angle is a right angle? WXY, right? So doesn't that mean that the measurement of WXY is 90 degrees? And that's because if we looked in the glossary for right angle, under the definition, it will say it is an angle whose measurement, is what we're saying right here, is 90 degrees. Measurement is 90 degrees. Okay? So now we've exhausted all our vocabulary words. Okay? In the last one, we had 3 vocabulary words that we actually ended up dealing with. Here's one, and now we're done. Okay? So we keep going on that list, that handout, and we get to step 4, and it says, if you develop a congruency or an equality in your vocabulary, you want to draw right in your picture, it might make sense to come up to my picture, guys, and do that. Okay, we know we put that little box inside that corner to tell us that's the right angle. That's probably a good idea. Okay, so that's matching up to that process on that handout. The next step 5 said, once you've exhausted all vocabulary, you've added to your picture, you want to look at your picture and see if there's anything from the picture that you can conclude to be true just by looking at the picture. Okay? And I'm going to kind of direct our attention to one idea, and it's because I see a bunch of angles here. But one idea that we are going to concentrate on and use a lot is the fact that those two angles are adjacent to one another, right? Can I add those two angles together to get that angle there? So I'm going to say step 4, that the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle WXY. And think about what we just did. We are adding two angles to get a third angle, right? Whenever you're adding angles to get a third angle, you're doing angle addition. So, angle addition postulate. I'm always kind of checking back to remind myself, does this line match up to that line? Because that's going to tell me how I'm done. Okay, so they're different, so I just keep going, keep plugging away. Look at these three statements. Do you have some things that you can replace? Everywhere I see an angle 1, what can I replace it with? I can replace it with 3, right? Or everywhere I see 3, I can replace it with 1. Everywhere I see measure of angle WXY, what can I replace it with? 90, right? Does that make sense? So you guys see that right here, that WXY, measure of angle WXY, and that measure of WXY, we could replace those two things? Okay, so instead of saying measure of angle WXY, I'm going to say 90 degrees instead. Okay? And I'm going to do this right here. I'm just going to rewrite that. Okay, and we'll talk about maybe an alternative way of doing this in a minute. But I'm just going to go do one substitution. I'm going to take statement number 4 and 5 are identical. Except for here, instead of writing WXY again, I wrote what it was equal to. So that's substitution, right? I'm going to write statement 6 the exact same way as statement 5. But let's look at statement 5 here. That says measure of angle 3, right? What's that say? I'm allowed to recall measure of angle 3. Measure of angle 1, right? Would you guys agree that those two things say the same thing? If 3 and 1 were the same thing? Okay, so because those two things interchanged, I replaced 3 with 1 and they were equal, that's substitution again. Okay, so some people might condense those two lines, 5 and 6, into one statement. Does that make sense? Okay, so if you wanted to go from 4 straight to 6, you could do that. Okay, because you're substituting just multiple things. So if I got 2, so think about what this says. You got 2 angles, 1 and 2, and they add up to 90 degrees, right? That's what that algebra says. You have 2 angles that add up to 90 degrees. What can you tell me then? How can you categorize or identify what angle 2 and angle 1 are as a pair? If they add up to 90, they are complementary, right? And hopefully you're starting to maybe see the necessity of learning the vocabulary and then hanging on to that vocabulary. Okay? I think, and then this is something that you guys can probably share, when I was a student and I was in like science class and we learned, words for working with DNA and all that kind of stuff, and maybe that chapter. Did that matter to me at all when we started talking about photosynthesis? That vocabulary is completely different, right, from chapter to chapter, and there's very little kind of overlap. So maybe that can be done with chapter 1 test in science, and then not have to worry about that vocabulary any longer. Okay? But in math, when I'm done with Chapter 1 vocabulary, I need that for Chapter 2. So I'm done with Chapter 2, I need 1 and 2's vocabulary for Chapter 3. So it's progressive. It's continually building and reusing those terms, so we can't forget them. Okay? So angle 2 and angle 1 are complementary. You just said you identified, classified, categorized these two angles as being complementary. So your reason for that will be the definition of complementary angles. That step right there, step number 2, we didn't use that until down here in step number 6. So the last class, our step number 5 was your step number 2. Does that make sense? Okay? This statement can actually float and be anywhere that it wants to as long as it's stated before I use it. Does that make sense? So we used it here. So I had to state up here somewhere that it was true before I could use it, okay? But it has to come after this because this is what allowed me to know that that was true. Does that make sense? So we call that statement number 2 because it can float and kind of go anywhere that it wants to. We call that an independent statement, okay? So we have to have an understanding of what independence and dependence means. Dependence means that it relies on something else, right? When you guys were in algebra, you guys learned some procedures. You said like 2 times x plus 3 plus 4 equals, let's say, 7. What would most people do in this equation first? Distribute. And they're going to go 2x plus 6 plus 4 equals 7, right? And then they're going to go 2x plus 10 equals 7, that kind of thing. But is it legal or is it okay to do this? Can I move that 4 over first? Okay, so the distributive property and then that moving of 4 are independent procedures. It doesn't matter the order that you do them. You're still going to arrive at something that is still true. Does that make sense? Okay. Now, in this situation, if I go that way, now I have to distribute here, right? So I then have to subtract 6. So subtracting 6, being able to do that and know that I can do that was dependent on the distributive property occurring first. Does that make sense, everybody? So you've worked with dependent and independence before. I don't know if you've kind of talked about that way. You've talked about independent variables, dependent variables, and the x, y axes. We need to be able to talk about them in regards to these statements in our proofs and understand how they can float if they're independent. Okay? No new homework. Keep plugging away at that 2.5. 2.5. I think it's 2.5. I get my numbers mixed up. We're in 3 different classes, and they're all in Chapter 2 right now. Yesterday's homework assignment, that's still open. It'll be due tomorrow. Optional review is open. Work on that. Okay, we'll review a little bit tomorrow. I got 1 or 2 more proofs that I want to discuss with you tomorrow as well.